Hello, do you hear me?
Yeah.
Fantastic. Seems like Zoom is not detecting my camera. It's fantastic. Ah, okay. That's slowly taking shape. Okay. We have three participants. Hello, everyone.
Hello.
We're
Hello.
gonna be a more of an intimate group this time. But don't worry, we should have more students joining uh, next few minutes. If not, we also have some other students from McGill who will also be participating in the event that aren't joining this meeting. So don't worry that it's such a small group. I will. Oh, I'm always so bad with these things. Zoom. Classic question. Do you see my screen?
Yes,
Yeah.
yes, we do.
Okay, fantastic. Do you hear me fine?
Yeah.
Yeah.
Okay, good. Um, well, I'll give it, let's say, 2 more minutes before we start. Um, I guess before we start, do you have any questions about the event? Worries, concerns? Please ask away, so I know maybe how to steer this meeting before we start.
None that I can think of right now.
Okay.
Do we have access to like the resources at McGill? Like maybe the computer lab or like the your 3D printers, stuff like that?
Um, that's a very good question. So I will be on campus, and so will many of the mentors. So likely what will happen is if you will want to use some type of equipment, you would have to just coordinate with one of us, and we'd be there helping you. Um, because normally you're not really supposed to have access to these things, but the lab technicians also are very open to this event and like the idea. So it seems like they are willing to make some exceptions, but these details are being currently sorted out. But I would say that, um, at least me personally, I would make sure that if you would need to use something at McGill, um, that I will be there available to help you with these projects. So a tentative yes depends on what you would exactly need, but a 3D printer isn't a problem at all.
Perfect.
Okay.
Thank you.
Seems like it's 6:03, so I'll get started. So I guess as a first thing, thank you for um, being interested in the event. We think that this is a very interesting opportunity for young students to explore different, aspects of science before committing to a, bachelor's degree and just getting to familiarize yourself with the department before actually coming here. It seems like having hands-on experience and surrounding yourself by different professors and academia and research um, correlates very well with how uh, I don't want to use the word succeed, but your prospects in meeting professors and kind of getting a better understanding of how all of these things work, of course, means that you have more experience and therefore better outcomes in your research endeavors down the line. So yes, basically, if it maybe wasn't clear, actually, maybe I should ask, have all of you looked over the website or not entirely?
Not entirely.
Okay. Um, yeah, so I'll quickly go over everything. Since we're only a few people, I will give myself the leniency to just ask one-on-one questions as well, if you want, at the end. But basically, right, the idea of this event is that, um, oh, it's not in June. On July 3rd, which is a Friday, we will be hosting an event at McGill where, right, any passion projects you may have, that's related to physics, you'll be able to come and present them to the department, have some posters, meet professors, visit labs. So in that sense, it's not really necessary for this to be a very big event because the more people there are to coordinate with, oftentimes the less personalized the experience is. But anyways, um, as outlined here on the bottom, right, you'll be able to essentially how the day will look like. I guess I should probably go into the schedule. Is right, get at McGill bright and early. We'll have an opening ceremony where different sponsors will be well, first of all, I guess giving you a pitch of exactly what kind of prospects you may have as a career in physics after graduating with a bachelor's degree without necessarily having to go into academia, being a professor, grad school. And then we're going to have a long 2-hour poster session where you will get to meet different professors who will come up to your poster, ask you questions, and just discuss the whole process of doing a physics related project and kind of the different ideas you came up with and how you solved different problems you faced. Um, which poster sessions are a very good experience, I think, to be meeting different people and networking, but also getting to know different questions that you maybe not have considered throughout your whole experiment or project. Um, often opens up your eyes a lot on how you could explore different sides to some project that you never considered before. Um, anyways, we'll have lunch and then a Q&A panel where hopefully you come in with some questions that you were wondering about, career in physics, and professors from our department will be answering your questions. And then a small break, we could also just talk more personally with professors and some of the sponsors at the event. Then we're going to have a session where depending on the size of the event, we will either split into groups or we'll have students all together just visit different labs at McGill. Mostly experimental because those are more easy to present, but we'll hopefully have some theoretical groups as well come in and give some short talks on what they're doing. And then we have a 3-minute thesis component where basically you would go up on stage and break down your whole project into a much smaller, condensed version. Um, and this is actually inspired by an actual competition held in Canada, which is called the 3-minute thesis, where people from various backgrounds, biology, chemistry, physics, engineering, mathematics, coming in and talking about the research. And these are often PhD level students, and so it's quite difficult to break down your research so so that a general audience can actually understand what you're talking about in a 3-minute talk. So oftentimes what people do is they kind of try to present their work in a much more artistic, um, general sense, uh, which is a very interesting challenge because it forces you to think about your problem in a very different way. Something that, doesn't really go into the specifics of your project, but still presents the general idea of what you're trying to achieve. And then judges will take their breaks. We're going to have a closing ceremony, give out some small awards, and then enjoy a dinner to finish the day off. So that's how the event will look like. And guessing a lot of you read this about page. Um, we do think that this event, for the most part, is going to be a really interesting way for all of you to just get in, dip your feet into doing independent research and actually having, physics students from our organizing committee also ask you some difficult questions and lead you on to actually hopefully build a project that's a lot more developed and I don't want to say precise, but uh, target some more interesting ideas that we think would be cool to present. Um, yes. Otherwise, I don't remember exactly. Have all of you selected a problem already to be working on, or not yet?
Not yet.
Not yet.
Sorry. Noor, are you talking? It seems like I'm having trouble hearing you. I
Did
don't
you
know.
can you hear me now?
Yes, I hear you much better.
Oh,
Yes.
okay. Yeah, no, I said that I did not. I have not yet gotten one.
Okay.
Chosen one.
And what about the rest of you? Do you have any ideas for what you want to be working on, or
Not really at the moment.
okay?
Yeah, we'll figure things out.
Sorry, you do or you don't?
Nope. I'm
Okay.
a Efi, so
Ah, okay, 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 okay. All right. Um, if I remember correctly, when you registered, you were also mentioning a third person who might be interested in joining. Are they still interested or not really?
yeah, I think he still is.
Okay, fantastic.
He
Um,
is. He has something to do the morning of the expo, so not sure if
okay,
we can fit things through.
okay. Um, yeah, unfortunately, we won't be able to change the dates, but um, they're more than welcome to come in at any point in the day. Obviously,
Yep.
there's no restrictions on that. Um, yes, so I guess one of the big questions is, getting started. So we do have, I don't know if you saw this, a problem section on our website, which gives some example problems that we think are accessible for you to get started. Now, I should stress this that, what you'll find is often the case in these research projects is that it's very tempting to start with a problem that's very complicated and try to get a satisfying and interesting answer to one of these problems. Um, but often what happens is that you're going to face a lot of obstacles in solving this problem. And what's often a lot more fun as well is just trying to set up a question that's surprisingly easy. Like, for example, I'll give an example of blowing horn. This is actually one of the problems that was suggested for undergraduate students at, different universities around the world to work on. Um, and it sounds like a very simple problem, but when it actually comes to, so I guess I should probably preface by saying that this is a problem where you try to build the loudest horn possible that's constrained in size to a cube that's 30 centimeters in size. And suddenly having to consider, building something like this, there are a lot of questions that you need to ask yourself before even starting this problem. And so what we found to be a lot more effective with students in these competitions and problems is to select a problem that's actually quite easy and try to dig deep as you can. Because in these cases, what ends up happening is you will be facing different obstacles along the way, and then you're forced to make a decision, whether it's in your design or how you measure things in your experiment. And these are a lot more revealing about how research actually happens on a day-to-day basis in labs. Because if I think about what I was doing half an hour in my lab, it's aligning a laser to a sample. This is not a complicated thing, but given the constraints of the things you're doing in a lab, um, coming up with an interesting solution to this often takes a surprising amount of time. And sometimes you're faced with questions that you don't know exactly how to answer that are completely unrelated to what you're trying to solve in the first place. And so solving those side questions first are also very interesting to present in a showcase. So all to say, we suggest often in these cases for students to just select something that's not too complicated. And what I've always tried to convince undergrads to do is to do a quick and dirty experiment at home with the most minimal amount of equipment that you have that you would need, and basically um, try to find all of the different things that come out by just changing different parameters. And these small experiments are often far more revealing than students then going headfirst trying to solve something, because we often get a small blind spot to the problem because we're so focused on one detail that we kind of lose the bigger picture. So, anyways, all to say, We have a big list of different problems that we think would be interesting for you to try. And hopefully these are accessible. Have you all looked at this problem list before or no?
Yes.
Yes, okay. Has anything caught your eyes, or I guess maybe more generally, do you think these problems are a bit difficult, or I would love to hear some feedback.
If anything, I found they were a little bit easy. Maybe that was just
Okay,
the ones I was looking at, but
okay,
I don't know.
good. Um, so okay, in that case, what I would ask for you after this meeting is to look at these problems and just select one or two or three, however many you like, that you are most interested in trying, and then just replying back to the email that I sent for this meeting. Um, and then I will, and also in that email, please let me know what times you are available to meet so that we can meet, one group at a time and discuss, how to approach one of these problems, or if you have something else that you just so happen to be interested in that are, you don't have to choose these problems. It could be anything you want. Um, and we could just brainstorm some ideas of some things you find interesting in general that you could maybe work on, or if you select something from this problem list, how to maybe first tackle these things. Does that sound like a plan?
Yeah.
Good.
Okay, fantastic. Um, yes, I very small meeting. There's not too much detail that I need to really go over. As long as you know what the event is about, I think the first steps to maybe clarify would be sometime this week. Ideally, we would meet, or over the weekend. That's okay too. To meet and just discuss a problem that you'd be interested in working on, and then just brainstorm some ideas, and then converge onto a choice, and then in that private meeting, we'll be able to uh, hopefully discuss your first steps and actually getting started with your problems. For a general timeline, I would say for these problems, we do have around 2.5 months to solve. So, the expectation here isn't for this to be a fully completed problem. It's really more to see where, your creativity, your thinking, and your experiments take you and being able to create a poster. So I would say that for the first month and a half, it would be mostly just brainstorming ideas, trying different things on your problem, and just getting familiarized with how this whole thing works. And then in the last month, the first 2 weeks of the last month would be you actually doing some final runs on your experiment and hopefully getting some final data. Um, and then the last 2 weeks would be putting everything together into a presentation, into a poster, getting those printed, and well, we'll be handling the printing. And then yes, coming to the events. I would say in the first month and a half, as you're tackling these problems, there's going to be a lot of different questions that you're probably going to be facing with, like, what are the parameters I care about measuring in this question? Uh, what are some of this is a sorry, I didn't hear you. Oh, you weren't
I
asking a
didn't,
question.
I didn't say anything.
Okay, sorry. Yes, so one thing that you often hear people say in research is when you're writing a paper or you're working on a project that you're hoping to publish, one of the first questions that a professor will tell you is, what are the figures you intend on presenting? So what are the images that you're trying to present? And these often are graphs or experimental setups. Like how does it look like? Um, and these are a very good way for you to consider how you're going to approach this problem. Because if you can imagine one figure is a graph, for example, then you're only presenting, how one thing changes with respect to another. And there's only so many things you could tweak in an experiment before it takes too much time, uh, or you're going too much into detail. And so this way of thinking is very helpful in kind of parsing this problem into something that's a lot more approachable. So maybe when you first sit down, do a bit of reading, watching some videos online, you might see that there's a big list of parameters that you're considering. And then as you're trying things at home for the first few weeks, doing some more reading, you might see that some parameters are a lot more interesting to investigate than others. And so this list shortens down to ideally have only a few parameters, like three, maybe four, which you will actually do experiments on. And then this brings you to your next question of how am I actually going to build an experiment that targets these things and changes them in a precise and uh, careful way. And then as you're slowly building this experiment, you're doing different trials. Hopefully, within the first month and a half, you'll not only converge on an experimental setup, but also uh, you should be doing some small analysis along the way, which means maybe doing some things in Excel, or we could also be doing some coding in Python to do some data analysis. Which, yes, if you don't have any familiarity with coding, we are here to help, and we will be giving some workshops on doing so. And by the end, basically in the last month, you already have your code or analysis pipeline set up. You already have your experiment basically figured out. And so you're just thinking, a couple of days to really sink your teeth in this experiment, do your final runs, put everything together. So I would say a good goal would be that sometime in mid-June, we will be, or beginning June, you'll be finishing up the experiments and uh, kind of coming up with a clear idea of how your final trials are going to look like. And you should already have a pretty good idea of what the results you expect to see. So that's pretty much it, I think, timeline wise. Uh, so, yes, one step at a time. So, if you have any questions, please ask or write in the chat, and I will happily answer. And then please, yeah, I guess any questions.
No, it all sounded very good. It's we still have to think these through. Uh, is there something glitching? Like, can you hear me?
Yes, I do. Yeah, yeah, yeah,
Oh,
sorry.
okay. No, it's just um no, I don't think I have any particular question. I think I have to discuss with Ife more to figure things
Yes.
out. Definitely.
So, yeah,
And
this is like a more general kind of explanation for to everyone, what the timeline will look like.
yeah.
Um, Also, like, I do want to put like an emphasis on how, these problems do not have to be complicated. And I'm glad you're saying they sound easy, because at least in my experience doing such problems, it always comes across as, wow, this is really easy. This will only take a few weeks, and then it doesn't.
Yeah.
So, um, and it's often like actually pretty cool to start a problem that you think is very interesting, and very simple. Um, And then you kind of, after like just a few trials, you realize, oh, this is actually, a lot more interesting and a lot more complicated than I thought. And suddenly, a problem that is, initially to you very simple and so very easy to explain to other people. Suddenly you have like these random facts about an everyday thing that everyone notices and it seems very simple, but actually has a lot more complexity to it than everyone imagines. So yes, just to say, by all means, if you think you want to explore like more complicated problem, go ahead. Because of course, more complicated problems have more complicated, behavior and physics involved. But don't be demoralized if you don't get too far because these things are complicated, but are always a fun little challenge to really get you thinking about, experimental design and making things as precise and accurate as possible. But anyways, anyone else have any? Oh, yes, please.
To show our our results of the experiment, is it just can it be like done outside or like is it always like in like an auditorium and just
Oh,
posters?
you mean for the actual event?
Yeah, for the actual event.
Okay, so likely what we're gonna do, depending on how many students sign up, we did have like I would say at least double the amount of people who signed up initially. I guess didn't join the meeting. That's okay. Maybe they weren't available, but depending on how many people sign up, what will likely happen, I will assume that for it's going to be an event that's 10 to 15 people. This is more than enough space we have in the Rutherford building, which is the physics building at McGill. There is a big conference room that we were able to book. So this would be basically, you know, basically looks like a classroom. And we will put up basically these cork boards. I don't know how to call them, where you'll be able to just put up your posters that are printed on those, and that's going to basically be where you're going to be doing your poster showcase. And whereas for your presentations, same thing. You'll just be presenting in front of this small, I don't want to call it classroom because it looks a bit more open. But you can imagine that as basically like a
Yeah.
classroom setting.
So we don't have to do like any demonstrations, like,
Sorry?
any like demonstrations of the experiments.
Oh, well, I mean, listen, by all means, you can imagine, in a classroom, you do have, well, I guess in this case, it's not desks, it's more like larger tables. So you will have plenty of space to set up an experiment if you'd like and actually show it off. We encourage this, actually. That's a good question. That's a good point. Um, no, if you'll have something that you could come and present, that is all the better because you can imagine, professors are going to be more, there is something in front of them that they can actually interact and see. So it is more engaging to have something in person, and you will absolutely be able to bring something like that if you'd like.
All right.
Yeah. Anything else?
Nope.
Okay. Well, if there aren't any questions, if anything comes up and you're unsure, please just email us. We do have, I will contact us. Here's our email, mipt.physics@mcgill.ca. You can email us here if you have any questions, and do use this email to let me know when you are available to meet to discuss more specifically on what you would like to work on. And yes, so there isn't anything else. I will stop sharing my screen and yeah, end the meeting here.
I do have a question.
Yes.
Is it necessary to be in a group or is it allowed to be alone?
Oh, you're allowed to be alone. We did say initially, because we weren't sure if, there's going to be a bunch of students signing up and then, it being a very complicated thing, but um, we do have plenty of money to also support your experiments. So you don't have to be buying things yourself. And so there is no worry about you being alone, or, whatever works best for you, we will encourage. And so don't worry about if you don't have a teammate to work with. Yeah.
Perfect. Thank you.
Yes, I probably should have emphasized we have funding available, so you won't have to be paying anything out of pocket to build these experiments. That's another thing, right? Like, you might have some cool idea you want to work on, but it costs a lot of money to do it, and you just don't want to dish out, 100, $200 on an experiment just for fun. So we encourage this type of behavior here for this event. So if you want to be buying some equipment, that's no problem. We also have equipment available to give out, depending on what it is. And also, CEGEPs and schools do also have equipment in their own labs that we should be able to use as well. So yeah. Anything else?
Is the limit for equipment and like uh, purchases still $100 or is that changed?
I will say tentatively, yes, $100. But I think this will be easier discussed privately to kind of sort out the details because a lot of
Okay,
things we do have access here at McGill, and so should be able to be giving some equipment for your projects from what we have here. So yeah.
For sure.
Any other questions, concerns? Okay. Well, in that case, I will end the meeting. Thank you everyone for joining. And yes, if you have a chance, please let me know of your availabilities, and I will try to meet with you all of you as soon as possible.
All right. Bye bye.
Okay. Thank you.
Thank you.
See you.
Bye.